Today's video will demonstrate how to determine the level of quality of a function as it pertains to cohesion. Hello, I'm James Helfrich. There are two modularization metrics. First is cohesion and second is coupling. Cohesion relates to the quality of a single function and coupling relates to the information interchange between functions. This video will demonstrate how to determine the level of quality of a single function as it relates to cohesion. We will start with a definition of cohesion. Cohesion is a measure of how well a unit of software, usually a function, does one thing and one thing only. Notice there's two parts to the definition. Does one thing, which means does it completely, and does one thing only. In other words, it doesn't do multiple tasks. There are several levels of cohesion. One is strong, and all aspects of a function are directed to perform a single task, and that task is completely represented. Extraneous. And extraneous means the function does a task completely, but it also does extra stuff or extraneous things. Partial, which means a function does not quite a complete task, but doesn't have anything extra. And finally, weak. And weak is not only does it not complete a task completely, but also does extra stuff as well. So let's take a look at strong. Strong is the most desirable form of cohesion, and really we try to make sure that every single function is strong cohesion. So take a look at this example. This function computes pay, and it both computes normal pay, which is from under 40 hours a week, as well as time and a half for overtime. Every single line of code pertains to computing pay, and computing pay is done completely. Therefore, this is strong cohesion. Now, extraneous means I do something extra. In other words, I have stuff in the function that does not pertain to its main task. For an example, take a look at this version of compute pay. So not only do I compute the pay, but I also output a warning message. The warning message is not directly related to computing pay, therefore it's extraneous. Partial means I do not completely complete a task. I do part of the task, but not all of it. So here, once again, we have our compute pay, but now I have two parts of it, the overtime pay and the normal pay, neither of which is complete without the other. If these two functions stood alone, then they would be called partial cohesion. And the final is weak. And weak cohesion means I don't completely do a task and I have extra stuff as well. So in this case, I compute my total earned, which is not really related to computing pay, and I don't completely do compute pay because I don't handle the non-overtime case. So let's take a look at a more difficult problem. Here we have a function in C++ called parse full name from text. On the surface, it looks like it does one thing completely. I'm going to take the input with Schmidt, John Jacob Jingleheimer, and turn it into a collection of strings, Schmidt, John Jacob Jingleheimer. But as we look at it more carefully, we realize that we're making certain assumptions. The assumption is that the input is in a certain format. If it's not in the correct format, then we have a problem. Therefore, we're going to rely upon another function to do some of the work. And that work is going to put the string in the correct format, or it's going to validate the format is correct. In either case, this function does not do the complete job. And since it doesn't do the complete job, we would call it partial cohesion. Let's take a look at a separate example here. Here I have a function called hit detection written in Swift. I take two elements and I'm going to return true if they hit and false if they don't. So what I'm going to do here is I'm going to find the distance between the two elements. And then if the distance is less than the combined radius of the two, then I'm going to return true with a hit or false, they haven't hit. So on the surface, this does in fact look like I have strong cohesion. However, we have a problem here. Not only am I going to determine whether they hit, but also I'm going to kill them, which means I'm doing two things. The name of the function, hit detection, does not completely represent what it does. I'm not just detecting a hit, I am dealing with a hit, and that means I have extraneous cohesion. This is example 12.1 and 12.2 in the cohesion chapter of the software design textbook.